Okay, so in this video we are going to be working on the warm-up for day 2. Okay, so we have some basic questions involving work, power, and energy. Okay, so the first question, let me make this a little bit bigger. The first question says a crane lifts a 1,400 kilogram car 25 meters into the air over a time period of 14 seconds. And the first question says calculate the work done by the crane in lifting the car. So remember that work is force times distance. Okay, now we are given the distance that the car is lifted. That's 25 meters. That's my D. But if you look everywhere in the problem, we are not given the force. Okay, and so you need to know, because it was in the notes, that in order to lift a car, the force that you have to apply to lift the car is equal to the weight, aka the force of gravity, of the object. Okay, now that force is mg, the mass of the object, times g, the acceleration due to gravity of the object. Okay, so that would be 1400 times 10. I've had some people ask me why is it, positive 10 and not negative 10, because the negative 10 meters per second squared, the acceleration due to gravity, the negative sign indicates direction. In the context of energy, that direction doesn't really matter, at least not in this level of physics. Okay, and so that's why we're making it a positive 10 and not a negative 10. Okay, so when I go to plug in, the force I'm using to lift the 1,400 kilogram car, remember kilogram is mass, is not 1,400 but 14,000. So 14,000 times the distance, which is 25. Also remember that if it has a W after a number, that's not work, that is watts. Okay, so don't confuse the two W's. W used like this, or it's equal to something, that W is for work. If it comes after a number, it's for watts. Okay, so if you plug that into the calculator, you should get 350,000 joules, and that is the work done by the crane to lift the car up into the air. Okay, pause it there if you need to take a look at that. Okay, so moving on to question B. Alright, now remember that work was 350,000 joules, so I'm going to erase this. Okay, remember that power is how quickly work is done. In other words, power is work over time. So we have that 350,000 joules of work that was done divided by the time, which if you read the question, the time was 14 seconds. Okay, so that is your time. So we want to divide 350,000 divided by 14 seconds. And if you do that, you should get 25,000 watts. Okay, notice again that this W comes at the end of a number. That means I'm using it as a unit for power. Okay, so 25,000 watts is the power exerted by the crane to lift the car. Remember, power has to do with how quickly that energy is changed over time. Pause it there if you need to look at that. Okay, now question C is kind of an interesting question. It says calculate the gravitational potential energy of the car after it has been lifted up into the air. Now the equation for gravitational potential energy is Eg equals mgh. Okay, that's the equation for gravitational potential energy. Remember, that's energy that's stored from the height of an object above the ground. So we have the mass of the object is 1,400. We have g, the acceleration due to gravity, which we're going to use a value of positive 10 meters per second squared for that, times the height. Okay, well, if it's lifted 25 meters into the air, then the height above the ground is 25 meters. And so if you multiply 1,400 by 10 by 25, you get 350,000 joules of gravitational potential energy. Okay, now, if you take a look at that, you might think to yourself, wait, wasn't that the same answer for A? In question A, we calculated the work done by the crane. In question C, we calculate the gravitational potential energy of the car after it's been lifted, and they turn out to be the same number. Okay, so you might ask, is that a coincidence? And the answer is no, of course it's not a coincidence. Remember that the concept of work, okay, we've done problems with work calculations, but remember the concept of work is the transfer of energy to or from an object. If it's positive work, you're adding energy to the object. If it's negative work, you're taking energy away from the object. Okay, so in question A, we found that the work done, that means the transfer of energy was 350,000 joules. Okay, that means that the crane put 350,000 joules of energy into the car. Okay, now work is not a type of energy, it's just the transfer of energy. So then you have to ask yourself the question, okay, so the car gained 350,000 joules. What type of energy did that go into? And the answer, of course, is gravitational potential energy. Okay, that's why the answer for A and C are the same. Okay, so question A basically had to do with how much energy was transferred to the car, and question C basically had to do with how much or what type of energy the car gained from that calculation. Okay, and it's gravitational potential energy. Now, if the crane were to drop the car and the car were to fall all the way down to the ground, then it would lose that gravitational potential energy, and it would hit the ground with 350,000 joules of kinetic energy after it finishes falling. Okay, so remember, energy cannot be created or destroyed, but it can change forms like that. So hopefully you feel a little bit better about the work, power, and energy calculations after watching this video. I will see you guys in the next video. Please let me know if you guys have any questions.